All right, in this video, we're going to talk about suggested homework problems from 7.1. Our topic is going to be area between curves. This is our last video for our Calculus 1 suggested homework problems. And let's talk about how we're going to set these problems up. So we're going to have a bounded function or an area that's bounded between two functions, let's say like this, from a x equals a to x equals b, and we have some function that's upper, and I'll call that f for right now, and some function that's lower that I'll call g. And so this is going to be f minus g of x dx from a to b will be my area. If it was the other way around and g was my upper function, I change the order of subtraction so that it's always upper minus lower, so that I get a positive number in the difference between the y values. If it's easier for some reason for me to integrate with respect to y, and I'll go c to d of f minus g of y dy. In that situation, I'd have something possibly that looked like this. Just as an example of here's c to, here's c to d on y, right? And I'm interested in this where my f of y is to the right, my g of y is to the left. And so do I want my rectangles, my shading, to be going up and down? I use dx. If I want my shading, my rectangles to go left to right, then I use dy. It's my choice. We'll get to a problem later where we have to do it both ways and then make a choice of which way we like better. So let's start with number 5 here. Y1 is equal to x squared minus 6x. Y2 is equal to 0. They're going to give us the picture for this so that we don't have to find any points of intersection, but I will find the points of intersection here for you. I don't like reading them off of the graph. X squared minus 6x, set it equal to 0, and factor x equals 0, or x minus 6 equals 0, x equals 0, x equals 6. So this is 0 and this is 6. Coming back here, this is 0, 0, and 6, 0 for my points of intersection. So I'm going to have bounds from 0 to 6 of upper function minus lower function dx. So that is 0 to 6 of negative x squared plus 6x dx, and that's enough setup. We're not supposed to solve. Number 6 says y1 is equal to x squared plus 2x plus 1. Y2 is equal to 2x plus 5. Again, I'm not going to trust the graph and my eyeballs. I'm going to use algebra to tell me where the points of intersection are. So they are at x equals negative 2 or x equals 2. And so that tells me that I'm at negative 2, 1, and 2, 9. By plugging into here, I'll get the same y value for the linear or the quadratic, but the linear is easier to solve for. So I usually use the lower degree function, the easier function to evaluate to get my point of intersection. So going from -2 to 2, my upper function is my line. And the graph is helpful for that. Otherwise, you have to pick a test point that's in between and see which one gives you the greater y value to see which one is upper and which one is lower. So if I wanted something between -2 and 2, I could pick a 0, and this one has a y value of 1, and this one has a y value of 5, so y2 is greater than y1 in this interval, and that's why I've set up my interval that way. Let's go ahead and simplify this integrand a little bit. -x² minus 2x plus 2x is 0. 5 minus 1 is plus 4. Notice that's just the opposite of this subtraction that I did up here. So I'm either going to get the same thing as the subtraction that I did to set it equal to 0, or I'm going to get the exact opposite. Those are my only two possibilities, depending on the order of subtraction. So that's it for the setup for number 6. Let's look at number 7. It says y1 is equal to x² minus 4x plus 3, and y2 is equal to a -x² plus 2x plus 3. So again, not trusting my eyes to get the points of intersection exactly right. I'm going to set these equal to each other. This becomes 2x² minus 6x equal to 0. 2x times x minus 3 equals 0. X equals 0, or x is equal to 3. When x is 0, y is 3. When x is 3, which one is easier to solve here? This one or that one, it doesn't matter. Y is 0 because it's an x-intercept of both of those. So we're going from 0 to 3. Let's use 1 as a number in between here. 1 minus 4, that's -3 plus 3, that's 0 for this one. -1 plus 2, that's 1. 3 is 4, so y2 is bigger. -x² plus 2x plus 3. I can also see that the parabola that opens down is bigger than the parabola that opens up here. As I already told you, this is going to be the negative version of this subtraction here in this case, because I subtracted y1 minus y2 to get this, and it's supposed to be y2 minus y1, so I just changed my signs there. And there's all my setup. Let's look now at number 8. y1 is x² and y2 is x³. And when I set them equal to each other, x² minus x³. Actually, I want it the other way. x³ minus x² is equal to 0. So that turns into x² times x minus 1 equals 0. X equals 0, or x is equal to 1. So interval 0 to 1 of, now I got to think about which one is bigger, which one is smaller. In the interval between 0 and 1, pick any fraction that you want to. 1/10, let's say. 1/10 squared is 100. 1/10 cubed is 1,000. 100th is bigger than 1,000. So this is x² minus x³ dx. And that's it for the setup here. You can also maybe see here that the quadratic is above the cubic. The cubic is in light gray, and the quadratic is in dark gray, or is in black there. So let's look at number 9. 9 says y1 equals 3 times x cubed minus x. y2 is 0. I'm going to use symmetry here to help me with this one. I see that it's an odd function. I see that the area to the left and to the right here are the same. So I'm going to go with the one that's easier to get the signs here, which is this being the upper function, with 0 being the lower function, and that's from -1 to 0, and I'm going to double that. So this is 6, -1 to 0 of x cubed minus x dx, or you could say that this is -6 from 0 to 1 of x cubed minus x dx, or 6 times 0 to 1 of -x cubed plus x dx. All of those will be correct ways to set this up. Hopefully WebAssign likes all of them equally. I know that the textbook goes more for these options that are down here because it likes 0 to 1. It doesn't like using the negative number, but I like using the part where the bottom function is 0 and I have just this function here. I prefer that. I think that math is a little simpler than dealing with all the subtraction there. So 6 of one, half a dozen of the other. Let's move on to number 11. This will be sketching the region. They give us the integral now, and they want us to go backwards and find the region that it represents. So I have y-intercept of 1, slope of 1, up 1, right 1. I have this line. I have another line with a y-intercept of 0, up 1, right 2. And the point of intersection, I'll find it, but it isn't really interesting to me because it's outside of this interval. X plus 1 equals x over 2. 2x plus 2 is equal to x. X is equal to -2. This is -2 and -1 here. But my area of interest is from 0 to 4. And it's this region in here that I'm interested in. So so we're not supposed to evaluate and find the area. We're just supposed to sketch the graphs and shade the region. Let's look at number 13. 13 says -2 to 1. And watch out, these are functions of y. So everything is kind of backwards from what you normally think. So this is an x-intercept of 2. And instead of doing rise over run, this is run over rise. So -1, 1, so. This line, and then this is y squared. So this is 1, 1. It's a parabola that opens to the right, -1, -1. I'll tell you where this point is in just a second. So y squared equals 2 minus y squared plus y minus 2 equals 0, y plus 2 times y minus 1 equals 0, y equals a -2, or y equals to 1, and y is -2, which is down here. Then -2 squared is 4, when y is 1, which is up here, 1, this is at -2, then x is equal to 1 as well, and we're talking about this region that's bounded in here between y is -2 and y is 1, with the line to the right of the parabola. Let's look now at number 15. Y is equal to x squared minus 1, y is equal to -x plus 2, x equals 0, x is equal to 1. And we need to sketch the region, and then we need to integrate and find the area. So x squared minus 1, so -x plus 2, and we're only looking from 0 to 1. So in this region right here, the line is above the parabola. So 0 to 1, line above parabola, and that gives us 0 to 1, -x squared minus x plus 3 dx is a -x cubed over 3 minus x squared over 2 plus 3x from 0 to 1. Evaluating at 1, -1/3 minus 1/2 plus 3. Subtract, evaluate everything at 0. They all give me 0, so that's 0. This is -2/6 minus 3/6 plus 18/6. 18 minus 5 is 13 over 6. My answer for my area. So now at number 17. Says f of x is equal to x squared plus 2x, and g of x is equal to x plus 2. Notice I don't have any bounds limits set to my left and my right like last time, so I'm going to have to find the point of intersection with algebra. So x is equal to -2, or x is equal to 1, giving me points of intersection of -2 plus 2 is 0, 1 plus 2 is 3. Sketch my graph here, and I have x plus 2, so that is like this, and I have 0, 0, and -2, 0, and this is going to down, And then I have this point over here of 1, 3. I'm interested in what's in between them here where the line is above the parabola. So -2 to 1 of x plus 2 minus x squared plus 2x. That's opposite order of subtraction from what I had up here. So that's -2 to 1 of negative x squared minus x plus 2 dx is negative x cubed over 3 minus x squared over 2 plus 2x from -2 to 1 is -1/3 minus 1/2 plus 2 minus -8 is a positive 8/3 minus 4/2 is 2 minus 4 is going to give me, let's see, -1/3 minus 8/3, that's -3. Minus 1/2, 2 plus 2 plus 4, 2 plus 6 is 8. So 5 minus 1/2 is 10/2 minus 1/2 is 9/2. Let's look at 18. Eighteen says y is equal to a negative x squared plus 3x plus 1. Y is equal to a negative x plus 1. Set these equal to each other to find my points of intersection. So 0 is equal to x squared minus 4x, x times x minus 4, x equals 0, or x is equal to 4. So looking at the graph, negative x plus 1. So this, then negative x squared minus 3x, well, points of intersection are at 0, 1, so it goes through there, and it goes through 1, 2, 3, 4, -3 right here, and it has a vertex somewhere up here, goes up, comes back down. I'm talking about this shaded region right here, where the parabola is above the line from x is 0 to x is 4. And that's the opposite of what I did in this subtraction here. So that's going to be 0 to 4 of negative x squared plus 4x. Dx is negative x cubed over 3 plus 2x squared from 0 to 4 is a negative 64 over 3 plus 16 times 2, that's 32 over 1 times 3 over 3, that's 96 minus 64 over 3 is 32 over 3. So now at number 21. 21 says f of x is equal to x to the 5th plus 2, and g of x is equal to x plus 2. X to the 5th plus 2 is equal to x plus 2. X to the 5th minus x is equal to 0. X times x to the 4th minus 1 equals 0. X times x squared minus 1 times x squared plus 1 equals 0, x times x plus 1 times x minus 1 times x squared plus 1 equals 0, x equals 0, or x equals -1, or x is equal to 1. X squared plus 1 can never be equal to 0. That's why I didn't solve for that one. Take a look at this in the calculator for a second, just so I can show you the symmetry that's going on here. So x to the 5th plus 2 and x plus 2. It's a little hard for me to graph something that's 5th degree by hand. There's this very small area up here and this very small area down here that it's symmetric. They're the same measure. They're symmetric to that point right there. So by symmetry, this is 2 times, and then I can have -1 to 0 of, actually I prefer 0 to 1 here in this case, of the line minus the, okay, so this is 2, 0 to 1 of -x to the 5th plus x dx is 2 times -x to the 6th over 6 plus x squared over 2, 0 to 1. So that's 2 times -1/6 plus 1/2, and then it's 0. So this is 2 times -1/6 plus 3/6 is 2 times 2/6 is 2 times 1/3 is 2/3. Final answer for 21. Let's look at 25. 25 says f of y is equal to y squared plus 1. G of y is equal to 0, and y is between -1 and 2. So 1 and y squared opens to the right, x equals 0, y equals -1, y equals to 2. Solve these to get these points here. 2 squared plus 1 is 5. 1 squared plus 1 is 2. Right here. And we're talking about this region right here, where the parabola is always to the right, and I'm subtracting 0 from it. So I don't need to subtract 0. Y goes from -1 to 2. So y cubed over 3 plus y. -1 to 2 is 8/3 plus 2 minus -1/3 minus 1. 8/3 plus 1/3, that's 3. 2 plus 1 is another 3. The answer is 6. Okay, 29 is the problem that I was referring to earlier, where we're going to solve the problem 2 different ways. Going to sketch the region, and we'll have to do some algebraic manipulation on the functions as well. Start off with the region the way that it's graphed right now, or the way that it's presented right now. The x-intercept of 4, -y squared opens to the left with with 0, +2, 0, -2 as my intercepts there, and y 2. So x-intercept of -2 and we want right one, up one, when y is 2, x is 0, so it should go through here. I set these, so that's one of my points of intersection. I set these equal to each other. 4 minus y squared equals y minus 2. Y squared plus y minus 6 is equal to 0. Y plus 3 times y minus 2 is equal to 0. Y is negative 3, or y is 2. So y is 2, y is negative 3. Negative 3 minus 2 is negative 5. So we're going to use this region here. And so for part A, we're going to set this up where we integrate with respect to x. X is going from negative 5 to 0 with the line above the curve. So that is going to be, change this into y is equal to x plus 2. Change this into y is equal to plus or minus root 4 minus x, and we'll have to make a choice which that is. This is the lower piece of the parabola here, so this is going to be x plus 2 minus a negative root 4 minus x dx. And then we're going to add to that to get this region over here. I can only double, can't get both pieces. I need to double from x is 0 to x is, I look over here, this is an x-intercept of 4. So 0 to 4 of, and I'll just take this upper minus this 0 right here, so that's 4 minus x dx. So this is negative 5 to 0 of x plus 2 dx plus negative 5 to 0 of root 4 minus x dx plus 2 integral 0 to 4 of root 4 minus x dx. And I need to multiply by negative 1, divide by negative 1. This is an invisible 1. Multiply by negative 1, divide by negative 1. This has a derivative of 1. I'll just do this, x plus 2 squared and 1/2 from negative 5 to 0. This is minus 4 minus x to the 3/2 times 2/3. Negative 5 to 0. This is going to be minus 4/3 because it's going to be 2 times that 2/3, or negative 2 times that 2/3 that I'm about to get. 4 minus x to the 3/2. There's the 2/3. It gets multiplied by the negative 2 to make 4/3, and this goes from 0 to 4. So this is 1/2 of 2 squared minus negative 3 squared minus 2/3 of 2 cubed minus 3 cubed minus 4/3 of 0 cubed minus 2 cubed is 1/2 of 4 minus 9 minus 2/3 of 8 minus 27 minus 4/3 of 0 minus 8. So that is negative 5/2. Negative 19 times negative 2 is plus 38 over 3. Negative 8 times negative 4 is plus 32 over 3. So that is 70 over 3 minus 5 over 2 is 140 over 6 minus 15 over 6 is 125 over 6. That was part A. Part B is to set it up with respect to y. And so that's going to go from y is -3 to 2. And then it's always right minus left, so it's parabola minus line. So 4 minus y squared minus y minus 2 dy is -3 to 2 of a negative y squared minus y plus 6 dy is negative y cubed over 3 minus y squared over 2 plus 6y from -3 to 2 is -8/3 minus 2 plus 12 minus 27 over 3 minus 9/2 minus 18. So this is 10 minus 8/3 minus 9. It's -9 minus 9/2. 10 plus 9 is 19 minus 8/3 plus 9/2. Change everything to 6. 19 times 6, 54. 114 minus 16 plus 27 over 6 is 114 plus 11 over 6 is 125 over 6, which is the same answer. So part C says compare your answers. They're the same. It doesn't matter which way we do it, just one way may be easier. Which way was easier? In this case, it was easier to integrate with respect to y. Is it always going to be easier to integrate with respect to y? No, it just depends on the problem. In this case, it was easier because look at your region, that we had the same function to the right and the left all the time, and the bounds were no easier or harder. They're all integers here. It was harder to have to do above and below here and take the square root and think about the plus or minus the square root and use the symmetry over here and double, and all that was a much harder setup to integrate with respect to x. So I'm going to show you something now that you may think, well, my calculator only has an X button on it, so I have to always do it with respect to X because I want to use my calculator to tell me the answer. You shouldn't be using your calculator to tell you the answer anyways, but it really doesn't matter. The X is just a variable to your calculator, and it could be standing in the place of Y. So math, functional integration of, and we're going to go from -3 to 2 on the boundaries of my variable, and I'm going to have a negative variable squared minus the variable plus 6, and then d, and then that variable. We'll just call everything x, but it's really y. It's not drawing the picture for, so it doesn't matter. It's just giving us an answer. Math, answer to fraction, and we get 125 over 6, and that's the right answer. The calculator has no idea what the picture looks like, and it doesn't know the difference between x and y, just that it's a variable and you're integrating with respect to a particular variable. So you can swap variables out in your calculator and it won't make one bit of difference. Your function could be in terms of t and you can use x for it. So Let's go ahead and look at number 33. Now, this is one where I think we're supposed to use our calculator for something. I need to look at the directions again. So 33 says use a graphing calculator to graph the region bounded by the graphs of the function. So we're going to look at it, use symmetry if we need to figure out what we're going to do. So this is x to the fourth minus 4x squared. And this is x squared minus 4, zoom 6. And so we're interested in the area bounded by the graphs of the function. So what is bounded by the graphs? Well, we've got this area here, and we've got where red is above blue, and we have this region in here where blue is above red, and then we have this region over here again where red is above blue. So we have two of the areas that are the little areas, and we have two of the big areas. And so I'm going to use symmetry here. So I'm going to find where x to the fourth minus 4x squared is equal to x squared minus 4, x to the fourth minus 5x squared minus 4 is equal to 0, x squared plus 4, x squared minus 1 and x squared minus 4 is equal to 0, x plus 1, x minus 1, x plus 2, x minus 2 equals 0, x is equal to plus or minus 1, plus or minus 2. So I have two of the 0 to 1 regions here where blue is above red, and blue is the fourth degree. So x to the fourth minus 4x squared minus x squared minus 4 dx, plus another 2 that go from 1 to 2 where red is above blue. So x squared minus 4 minus x to the fourth minus 4x squared, like that. So this is 2, 0 to 1 of x to the fourth minus 5x squared plus 4, and then all my signs over here change. So I'll just pull the negative out to, I'll leave it in there because I want this to turn out to be a positive number. Like that. So this is 2 times x to the fifth over 5 minus 5x cubed over 3 plus 4x, and then 0 to 1 plus 2, and then opposite signs. Okay, so 2 times 1/5 minus 5/3 plus 4, the rest of it is zeros down there, plus 2 times negative 32 fifths plus 8 and 5 is 40 thirds minus 8 minus, stick in 1, negative 1/5 plus 5/3 minus 4. So those all become the same thing as this over here. So this is 3 of these. No, this is 4 of these because it's minus 2. It's negative 2 times the negative. 2 plus 2 is 4, plus 2 times this. Okay, so let's see what we can do with that. So this is 4 minus 64 over 5 plus negative 20 plus 80 over 3 plus 16 minus 16, that's 0. So negative 60 over 5 plus 60 over 3 is a negative 12 plus 20 is 8. Now it tells me to use the integration capabilities of the graphing utility to verify my results. So I have, let's just go ahead and stick this in, that this is math integration. And I have two times 0 to 1 of bars, y bars function. This is y1 minus bars, y bars function y2 dx plus 2 math integration 1 to 2 of, and then this is going to switch to y2 minus y1. So bars, y bars function y2 minus bars, y bars function y1 dx, and the answer comes out to be 8. So go with that one. Look at 38 now. It tells us to find the area of the region, sketch the region, bounded by the graphs of the equation, to find the area of the region. So 38 says f of x is equal to sine x, g of x is equal to cosine of 2x. And we're told that x is between negative pi over 2 and pi over 6. Let's pretend that they hadn't told us that we needed to find that. So sine x is equal to cosine of 2x. Recall that cosine of 2x is equal to cosine squared minus sine squared, which is also going to be 2 cosine squared x minus 1, which is also 1 minus 2 sine squared x. So all of these things are cosine of 2x. Because I see sine as my first degree variable, I'm going to use the one that has sine squared in it. Two sine squared x plus sine x minus 1 equals 0. U substitution, u is equal to sine x. 2u squared plus u minus 1 equals 0. 2u, u plus 1 minus 1, so 2 minus 1 is 1. So this is 2 sine x minus 1 equals 0, or sine x minus or plus 1 equals 0. 2 sine x is equal to 1. Sine x is equal to 1/2. X is equal to arcsine 1/2 is equal to pi over 6. Sine x is equal to -1. X is equal to arc sine of -1 is going to be a negative pi over 2. So there's our negative pi over 2 to pi over 6 that we get. Let's look at our graph to see now why that makes sense. So this is sine of x, and this is cosine of 2x. Make sure that you're in radian mode. I know I am. Make sure you are, and we're going to zoom trig here to help us see a better part of the graph here. And let's restrict our window now that we know it to be between negative pi over 2 and pi over 6 for our x's. So we see that the red function, which when I trace here, is going to be cosine of 2x, is bigger. We see our points of intersection though at negative pi over 2 and pi over 6 there. So our setup is going to be negative pi over 2 to pi over 6 of cosine of 2x minus sine of x dx. And I'll do my best to graph this region, negative pi over 2 to pi over 6 here, and from here through here, back down. That we've got negative pi over 2, -1. We have pi over 6, 1/2 up here, and we're interested in this region that is in between here. So integral negative pi over 2 to pi over 6 cosine of 2x dx, 2 and 1/2 to balance out, negative pi over 2 to pi over 6 sine x dx. So it's going to be 1/2 of sine of 2x, 2x being evaluated from negative pi over 2 to pi over 6. And this is going to be a negative cosine, so that's plus cosine x, evaluated from negative pi over 2 to pi over 6. 1/2 of sine of pi over 3 minus sine of negative pi plus cosine of pi over 6 minus cosine of negative pi over 2 is 1/2 of root 3 over 2 minus 0 plus root 3 over 2 minus 0 is root 3 over 4 plus root 3 over 2 times 2 over 2 is going to be 3 root 3 over 4 exactly. And 3 root 3 over 4 is approximately 1.299. Which will be our last problem for this video and this series. For Calc 1 is f of x is x e to the negative x squared, y equals 1, 0 less than or equal to y less than or equal to 1. So I don't really care how that looks, but I'll use my calculator to help me graph it since they told me to sketch the region. It's a little hard for me to picture without the calculator. X second e to the negative x squared, zoom 6. So we want to look at that from 0 to 1 on x. This is x. So window 0 to 1. Maybe we still give ourselves 10 tick marks. And let's make our window so that we go from 0 to 1 on y by tenths as well. Okay, that looks decent there, right? So I'm just going to sketch a graph here of this, and it looks like it comes up here and then doesn't come all the way back down. I'm interested in this region here, and this is 0, 0, and this is going to be 1, and then 1 over e. So what that will be. So integral from 0 to 1, x e to the negative x squared dx. I'll rewrite this a little bit. E to the negative x squared, x dx. U is equal to a negative x squared. Du is a negative 2x dx. I'm going to multiply by negative 2 on the inside and negative 1/2 on the outside. This is negative 1/2 integral of e to the u du. Let's change my limits of integration. Negative 0 squared is still 0. Negative 1 squared is negative 1. So because my limits of integration are backwards, I'm going to change the sign of my coefficient and swap my limits of integration like so. This is 1/2 e to the u from negative 1 to 0 is 1/2 e to the 0 minus e to the negative 1 is 1/2 of 1 minus 1 over e. And so let's see what that is. 1/2 of 1 minus 1 over e is right there. And this is about 0.316 when we round to 3 decimal places. So I've given you the exact answer. I've given you an approximate answer there. So that's it for this video, and might be putting up some chapter review problems later, but as far as the suggested homework goes, this is it. And I will be making a Calculus 2 series from the suggested homework problems from the textbook for Calculus 2 as well. So many of you that are in Calculus 1 will be going on to take Calculus 2, so be looking for those videos here. If they're not already up, they will be up shortly. So see you next time.